Okay, so I'm going to demonstrate the first lab. So I'll just restart it here. So I'm going to start by putting in the function generator. So this is going to provide our AC signal to the circuit. So we're going to need the positive lead, and then this will be connected to ground, so I can do that now. So we can go into here. So we're in sources, and we can click on ground, and we can place that there. And I think we're going to need another ground over there. So bring this down a little bit. Now we can go into here, and what's next? We should probably do the resistors. So we need the 330 ohm resistors. So these we connect here, and so this we put with the LED just to protect it. Okay, there's all of those. So now we can choose the LED, diodes, LED, and we'll do blue. Oh, do the blue LED. Okay, so that will just connect to each of the resistors. Oh, I should have. Hold on. That one there. Okay, another one there. And there. No, I'm gonna place this down here. So what we can do is we can just, to make it easy, I can just connect them all like this. Makes no difference. This works the exact same way. But it's a little bit easier just to put one ground on each of those. Okay. And oh. So next I will place the IC. So we want to come into TTL for the 74 LS ICs, and we want the 393 difference between D and N. I have no idea. So just choose a random one. This one works. So also gonna need a DC power supply. Okay, rotate that a couple times. Okay, that should be pretty much everything we need. So we got the positive lead of the DC power supply here. That's gonna come into our power. So this is our binary counter. So what it's gonna do is, as the clock pulses come in from our function generator, that's going to be counted. So each time a high pulse comes in, that counts as one clock pulse. And so the output is then going to output these clock pulses, or the count of it, using its 4 output terminals. And so if we connect these to the LEDs, you'll see them turn on, representing like a binary 1, 0. So I think we want to go, I think you start, yeah, so A is going to be this one, B will be this one, and C, and then D. And then this is our clear bit, and the clear bit just needs to be grounded. And here is our analog input, and so that is coming from our function generator. We can set this to 5 volts, and we can set this to be square waveform. 1 hertz is fine. Yeah, all this looks fine. Okay, and finally we just need to ground the IC. So, should have everything now. And we run it. Okay, it's going fast, but you can see it working. So it goes 1, 2, 3, 4, 5, 6. Yeah, it's a bit weird. So what it should be doing is should be turning both of these on together for 3. Doesn't seem to do that though. I'm not exactly sure why. This is the exact same as we've got drawn here. So it should be working. But for whatever reason, it doesn't like to turn them both on at the same time. Oh, I originally thought that could be because I'm using the same ground, which I don't really think makes sense, but just to give it a try, if we do individual grounds, you can see they should have turned on together there and they didn't for the number 3. Yeah. So the only other thing I could think is maybe the clear bit needs its own ground. So I could try that as well. But you know, it should all work regardless. Didn't change anything. Even if we make all this come together, I think I'll still see the same thing. Yeah, so it's still not turning them on together, but it is doing the count somewhat correctly. And as the circuit is shown, this is working, I guess. Are there any other components I need to explain? So I showed the construction, describe each component. I think I did that. So get the LEDs, resistors. Yep, I think I explained all that. I think I described so analog input, square waveform, reading the clock pulses, which are then used to create the count, and then the count is output through these. And so this is an analog input, and then these are digital outputs. So one just high-low signal.